Okay, let's have the solution to example 5.10. Okay, for the beam loaded as shown, find theta A, theta B, theta C, delta C, theta D, theta E, and delta E. EI is constant. So, with the limitation of our calculator, we should have a technique in computing the displacements. So if you consider A, B, C, D, and E, then this will be 1, 3, another 2 here, 5, 6, 8. So in determining, or there are 8 degrees of freedom. Because of the limitation of our calculator, we should have a technique on how to deal with this. So for instance, we consider A, D, and E only, or we consider A and D only, so that we can reduce the matrix to 2 by 2. So let's consider AD only. This is the strip. Then if we call X the distance from the 15 kilonewton load to the strip, then 30 minus 15 is 15, the height of this triangular load, 15 divided by 3, 5. So since there is already 15, so the height of the strip would be 15 plus 5x. So this is the effect of the load at A. This is at D, FA. Then we have fixed moment at D, called up FDL. So fixed moment AB can now be solved. So because we only consider AB, the moment due to the 15 kilonewton load at the overhang would be 15 times 2, so we have 30 there. Fixed moment AD is integral 0 to 3 of quantity 15 plus 5x dx times distance of the strip from A is 6 minus x, because that's x, so this is 6, so 6 minus x. Then distance of strip from the right is x plus 3, so x plus 3 quantity square divided by L square, which is 9 square, plus the fixed moment of the 12 kilonewton load, which is 12 times 6 times 3 square divided by 9 square. So fixed moment AD would be 83.75 kilonewton meter. Fixed moment dA, on the other hand, is same integral, except that 6 minus x is now square, and 12, 6 square times 3 over 9 square. X plus 3 is not anymore squared. So fixed moment dA is 86.5 kilonewton meter. So for the nodal displacement, so we have 83.75 clockwise here, so it should be counterclockwise. Counterclockwise, so it should be clockwise, negative 83.75. At D, this is node 4, because B is 2, C is 3, D is 4, E is 5. So 86.5 minus 30 is 56.5, because that's positive counterclockwise. So 56.5, 56.5 minus 30, 56.5. So let's now have the stiffness of AB and the fixed end forces FA, summation moment at D, so FA times 9 plus 86 plus this value here, this is 37.75. The equals 35 plus 1/2 of 3 times 30, the area of the triangle, times 5. 2/3 of 3, 2 plus 3, 5. That's 1/2 of 3 times 15 times moment arm 4. 1 plus 3 is 4. Plus 12 times 3. So FA is equal to 1396 over 36 kilonewtons. So fix summation versus y, FDL plus 1393 over 36 plus area of the trapezoid plus 12 equals 0. So FDL equals (1469 over 36 kilonewtons). So for the forces, we shade columns 1 and 7, so we can solve U2 and U8 as the product of the inverse of this 2 by 2 matrix times this force matrix here. These are the global forces. So U2, U8 equals negative 336 over EI. And it is the second value is 295.125 per EI. That corresponds to theta E and theta D. So considering DE this time so that we can solve delta E and theta E. This is the overhanging span. So FDR is expected 0 if you sum up moment at E. Imagine that D is fixed, E is fixed also. That's why we have to compute fixed moment when fixing forces. FEL is simply 15 upward. So FDR is 0, FEL is 0, is equal to 15, and there are no fixed moments. So KDE would be 12 divided by 2 cubed, so that's 1.5. And we already have an experience about this, so you just cut and paste those values. So DE is 7, 8, 9, 10. So we have 7, 8, 9, 10. Then for the forces, so we have 0, 0 FDR, 0 moment DR, 0. Then opposite to upward, 15 is downward, so negative 15, and there's no moment also at the other end. Then the displacement at 7 is 0, at 8 is already computed to 95.125, and we have U9 and U10. So we expand rows 9 and 10. These are row 9 and row 10. So we have negative 15, 0 equals this 2 by 2 matrix times the displacement matrix 0 and 295.125 plus this 2 by 2 matrix times this U9 and U10 matrix. So simplifying, negative 1.5 times 0 is 0, negative 1.5 times 295.125 is negative, transposed to the right, so positive. So negative 15 plus 1.5 times 295.125 is 6843 over 16. Then 0 minus 295.125, 1 times 295.125 is 295.125 to the left, so minus 295.125 times this matrix multiplication here. So this is 2 by 2. You can use your calculator easily to solve the value of U9 and U10, and they are 550.25 over EI and 265.125 over EI. which corresponds to delta E and theta E. Now, for the next, let's consider ABD. ABD. So AB and BD. So KAB would be 12 over 3 cubed. And we have already this result. So 4 over 9. So 6 over 3 square is 2/3. So we have the same result. You copy that situation there so that you don't worry about filling in these cells. Then BD is 3, 4, 7, 8 because D is 7, 8. So KBD is 12 over 6 cubed. First one is 12 over 6 cubed. That's 1 over 18. 6 over 6 square is 1 over 6. Then the negative of 1 over 18, you just copy 1 over 6. This is also copy 1 over 6. 4 over 6 is 2/3. 4 times 1 over 6, 2/3. Then negative of 1 over 6. Half of 2/3 is 1/3. The negative of row 3 or row 1, let's just call that row 1 in general. There are 4 rows. Then this is second row with column values at 2 and 4 interchange. So what is common here? 2, 3, 4, and 7, 8. 2, 3, 4, 8. 2 has displacement. 3 and 4 has displacement, then 8. So because we consider A, B, and BD, so A is fixed, B is fixed. There are no loads, so there will be no fixed forces as well as vertical load. There will be no. But for BD, fixed B, fixed B. So the span is changed. So we have moment BD and FDL and moment BD. So the span is changed. So FA, for the length of the strip, we call this X. So again, the height of the strip would be 15 plus, because 15 divided by 3 is 5, so 15 plus 5x again. So fixed moment BD is integral 0 to 3 of 15 plus 5x dx times distance of strip from B is 3 minus x. Its distance from D is x plus 3 quantity square over 6 square. So 6 plus moment due to the 12 kilonewton load, 12 times 3 square over 6 square. So fixed moment BD is 423 over 8 kilonewton meter. For fixed moment, dB on the other hand, 0 to 3, 15 plus 5x times 3 minus x squared this time, then x plus 3 over 6 squared plus 12 times 3 squared times 3 over 6 squared. So fixed moment dB is 27 kilonewton meter. So for our FBR times 6 plus 27 equals, this is 423 over 8 plus moment of the triangle with load 30. 1/2 of 3 times 30, moment arm is 5 plus 1/2 of 3 times 15, moment arm is 4 plus moment of the 12 kilonewton load 12 times 3. So FBR is 1005 over 16 kilonewton. Then summation forces y equals 0 for span BD only. FBL plus 1005 over 16 equals 1/2 of area of the trapezoid. So 1/2 30 plus 15 times 3 plus 12. So FDL is 267 over 16 kilonewtons. So the nodal load at 2 is no more. 423 over 8, which is D, which is the, because this is counterclockwise, 4 to 8 over 8. 423 over 8, so it is clockwise, opposite to this fixed and force. At node 4, we have clockwise fixed and moment TB27. By the way, we have FDBR here, which is because this is fixed and force upward, the nodal force is downward. And that is FDR, 1005 over 16. So remember, there's moment here which is equal to 30, 15 times 2. So the at node 4, at D, we have 27 minus 30, negative 3. So 3 clockwise. That's the only load because that's a support. KAB is, we copy the thickness of AB, 12 over 3 cube. That you see this slide. And for BD, 12 over 6 cube, the first term. And we already have this also, so we copy that part. Then for solving the displacements, unknown displacements at 3 and 4. So we have 2, 3, 4, and 8. So this is 2, 2. And 2, 2 is 4 thirds. This is 2, 3. 2, 3 is negative 2 thirds. So 3, 2 is negative 2 thirds. This is 2, 4. So T1, 2, 4 is 2 thirds. 4, 2 is 2 thirds. This is 2, 8. There's no 2, 8. So 0. So 8, 2 is 0. 3, 3. 3, 3 is 4 over 9 plus 1 over 18. So 4 over 9 plus 1 over 18 is 1 half. 3, 4. 3, 4. We have negative 2 thirds and 1 over 6. So negative 2 thirds plus 1 over 6 is negative 1 half. Then 4, 3 is negative 1 half also. 3 eighths. 3 eighths is 1 6. That's 1 6. So 6 8 is 6 3 is, sorry, 3 8 is 1 6. So 8 3 is also 1 6. 4 4. 4 4. We have 4 thirds here. 4 thirds plus 1 over 6. 4 thirds plus 1 over 6 is 2. Then 4 8, 1 third, 1 third. 8 4, 1 third. 8 8 is 2 thirds. So that's why we have 2 thirds there. So expanding rows 3 and 4 again associated with the unknowns. Although you can also expand rows 1 and 4 if you want. So we have negative 1005 over 16 and negative 423 over 8 is loads here and negative 3. So we have, because we have to expand this, so we have negative 2 thirds, 2 thirds, and 1 6 1 third. Columns 2 and 8 at 1, because only 2 and 8 have displacement, so negative 336 to 95.125 plus this middle 2 by 2 matrix, which is that, times U3 U4. So negative 1005 over 16 minus negative 2 thirds times negative 336 minus 1 6 times 295.125. Then here, negative 423 over 8 minus 2 thirds times negative 336 minus quantity 1 third times 295.125. The result is negative 336 and negative and positive 72.75 times this matrix here. So since this is 2 by 2, you can easily compute U3 and U4. corresponding to delta B and theta B. So they are negative 847.5 over EI and negative 175.5 over EI. So that's delta B and theta B, respectively. Next, now that we have found the displacements at P, so only displacements at C left. So let's consider AC and ACD. Let's consider ACD here. So KAC, because the span is A to C is 6, it will be the same as BD. So let's copy the force coefficients of BD. It's the same, except the numbering, because this time AC is 1, 2, 5, 6. Then CD, KCD is, since the span is 3, it will be the same as AB. So let's copy K of AB. But the numbering is different. It is 5, 6, 7, 8 for CD. 5, 6, 7, 8. Then let's compute global forces or nodal fixed forces, because it will change, because we consider span AC and CD this time. So this will be the effects. So CD, there are no loads between C and D, so zero fixed forces at C. We only consider AC. So this is our strip. We call this X. The height of the strip again is 15 plus 5X. And fixed, and there was moment here which is equal to 30. Remember. So fixed moment AC is equal to integral 0 to 3 of 15 plus 5x times distance from left is 6 minus x. Then distance from right from C is x, so x squared over 6 squared, plus moment of the 12 kilonewton load will be 0 because it falls over the fixed support, supposedly. So when the concentrated load is over a fixed support, there will be no moment, only the vertical reaction FCL would be its contribution. So fixed moment AC is 387 over 16 kilonewton meter. And fixed moment CA is equal to same integral, 6 minus x is squared this time, x divided by 6 squared dx. So fixed moment CA is 783 over 16 kilonewton meter. Then summation moment at about C is 0, F8 times 6 plus 783 over 16 equals 387 over 16 plus moment of the first triangular load with high intensity 30, 1 half of 3 times 30, moment arm is 2, about C, plus 1 half of 3 times 15, moment arm is 1. So FA is 117 over 8 kilonewton meter. Summation forces Y equals 0. FCL is 509 over 8. So FCL plus FA equals area of trapezoid plus 12. So 12 is included because we have some summation versus Y. That's why FCL is 509 over 8. So at node 1, we have fixed moment counterclockwise, so it is clockwise. And it is equal to 387 over 16. At node 3, which is C, we have FCL downward, 519 over 8. And this is clockwise or counterclockwise load, fixed moment CA, which is 783 over 16. 783 over 16, and a downward force of FCL, which is 519 over 8, opposite to the fixed forces. So we have to consider 2, 5, 6, and 8. 2, 5, 6, and 8. So at node 4, by the way, the loading is, because this is counterclockwise, so clockwise, 30. And remember, D is a support, so clockwise 30. So this is This is the stiffness of AC, stiffness of CD for our reference, and these are the nodal forces. Then forces, we consider 2, 5, 6, 8. 5, U5 is the delta C, U6 is the theta C. And we already computed U2 and U8. These are negative 336 and 295.125. So these are the forces, nodal forces. Again, we expand rows 5 and 6 associated with U5 and U6 or any other two rows. So let's simplify it. Negative 519 over 8, 783 over 16. So remember, we copy negative 1/6 and 1/3 and 2/3 and 2/3 times the displacement negative 336 and 295.125. Then the middle 2 by 2 matrix, which is this, associated with the unknown U5 and U6. So simplifying, negative 519 over 8 minus negative 1/6 times negative 336 minus 2/3 times 295.125. That would be negative 2541 over 8. 783 over 16 minus 1/3 times negative 336 minus 2/3 of 295.125 is negative 573 over 16. And let's copy that matrix. So since this is 2 by 2, let's solve directly the displacements U5 and U6, and they are negative 823.125 over EI and 187.875 over EI. So that corresponds to delta C and theta C. So I think everything is computed.